Good morning everyone. Today's our topic is Schmidt reaction. In this contains is introduction, mechanism, applications. Introduction. It is a type of named rearrangement reaction. Rearrangement reaction is also called molecular rearrangement. This rearrangement involves migration of an alkyl or aryl group with its bonding electrons from carbon to the adjacent nitrogen atom. That means here what happened means simply same like Beckmann rearrangement reaction. Here carboxylic acids reacting with azoic acid in presence of sulfuric acid. It can give amines. See here, carboxylic acids and hydrozoic acids react in presence of concentrated sulfuric acids to give amines. Here mainly Schmidt reaction, carboxylic acids, carbonyl compounds are involved in this reaction. Carboxylic acids, carbonyl compounds. Carbonyl compounds means what? Ketones or aldehydes. Whether carboxylic acid reaction with azoic acid in presence of sulfuric acid, they can give amines with the evolution of carbon dioxide and nitrogen gas. Whereas ketones, when reaction with azoic acid in presence of sulfuric acid, they can form amides and with the evolution of nitrogen gas. So here mainly involves three acids: carboxylic acids, azoic acid, sulfuric acid. It is giving amines. The basic reaction is carboxylic acids reacting with azoic acid, sulfuric acid, amine, formation of amines. See here, how the aldehydes gives. Whether ketones they are giving the amides, here aldehydes giving, when it is reacting with hydrozoic acid, with sulfuric acid, they can give nitrile and N-formyl derivative. This is the main compound, that is the nitrile formation takes place when it is reacting with aldehydes. Whether ketones reacting with hydrozoic acids, they can form amides. Carboxylic acids reacting with hydrozoic acid, they can form the amines. So this reaction closely related to Hoffman and Curtius reaction, of all which involves formation of isocyanate. Isocyanate. Simply if there is Cn means we can say cyanide. Whether it is in the form of NC, we can say isocyanate. Intermediate, the formation of RNC, that is called intermediates, that maybe takes place in carboxylic acids reacting with the hydrozoic acids, which involves formation of isocyanate intermediate to the migration of group from carbon to nitrogen. So here R is attached to carbon. Now this R, alkyl group, is migrating onto the nitrogen. The intermediate formation of the migration of R onto the nitrogen takes place. That's why it is a rearrangement reaction. Same like the rearrangement closely resembles the Beckmann rearrangement, where oxides are converted into amides. In this same also alkyl group is migrated onto the nitrogen. See the mechanism. Reactions with ketones. When the ketones in presence of acids, what happened? This H plus ion attack on the oxygen. Why? Oxygen is highly electronegative atom. It can take readily, it can give electron to the hydrogen. They can form OH by taking electron from carbon, and carbon is getting the positive charge. Now this is reacting with hydrozoic acid. The intermediate formation like this takes place. Hydrozoic acid means there is 3 nitrogens, N3H, N. and then H. So this is having rich of electrons. So that's why it want to donate electrons to the carbocation, and there is attachment of this nitrogen to the this carbon takes place, N3H. Actually it is in the form of H and double bond N and double bond N. Now this nitrogen is giving electrons to carbocation, and that's why this nitrogen is getting here, next nitrogen is getting positive charge. Then there is a loss of water molecule, and there is a formation of the this intermediate ion, and then there is a loss of N2. This is the unstable compound, so that's why there is a loss of nitrogen gas in the form of this minus N2, and here is we are getting the nitrilium ion. This is the main important one, nitrilium ion. Here is the actual rearrangement takes place. The migration of one of the alkyl group on the carbon to the nitrogen takes place. So that's why there is a formation of this compound. The intermediate compound formation takes place due to the migration of alkyl group from the carbon to the nitrogen. This is the actual Schmidt rearrangement reaction. And then in presence of water, there is the formation of H2O plus. The H2O plus ion is attacked on the carbon, and in presence of acids again dehydration takes place, and that's why there is the formation of the amide. So generally ketones, they can form amides. See, coming to carboxylic acids. Carboxylic acids are C double bond O OH. The mechanism involved means same again. In presence of acid, sulfuric acid, H plus can be denoted by sulfuric acid. This H plus ion attack on the highly electronegative oxygen, and the electrons are taken from carbon. Here we are getting the carbocation. Again in presence of hydroxylic acid, the formation of same intermediate like this. This nitrogen donates electrons to carbon, and this nitrogen is getting the positive charge. Now there is a loss of water molecule. In the intermediate ion formation takes place, and again loss of nitrogen, and then there is a formation of this intermediate compound. And after that, in presence of acids, this isocyanate formation. Already we discussed, mainly in carboxylic acids there is a formation of the isocyanate, not CnNC actually, or NC. This type of compounds are called isocyanate type of compounds. Cyanide Cl simply, but NC format is there, so it is called isocyanate because there is a carbonyl group is there. This isocyanate is very important one, and there is loss of water molecule and formation of the primary amides. So in the last reaction, ketones are giving amides, whereas carboxylic acids giving here amides. Ketones amides, carboxylic acids amides. Applications: preparation of primary amides. Example 1, it is a direct method for the preparation of primary amides from carboxylic acids and give usually better yield than the Hoffman or Curtius reaction. So here we are taking simple carboxylic acids, reaction with hydroxylic acid in presence of sulfuric acid. They are formation of the para-toluidine formation. Simply that is, this CO2 is removed from here and attachment of the NH2 group from the hydroxylic acid. Formation of the or NH2 type of compound, that is the para-toluidine. That means always carboxylic acid is giving the amides or NH2, or COH is converted to or NH2. Preparation of primary amides. So this is another example, preparation of lactones. Lactones, that means cyclic ketones, react to give lactones. Cyclic ketone, this is a ketone compound. They can generally form the amide type of compounds. So these ketones in presence of hydroxylic acid and sulfuric acid, they can form the caprolactam, COH, aldehyde form, and NH. When it is both linked together to form, we can say caprolactams. Same like Beckmann rearrangement reaction, there is a formation of the caprolactams. Another application is, if excess of hydrozoic acid used, there is a formation of cyclic ketones. That is like here tetrazones. When we can use simply cyclic ketone with 2 moles of the hydrozoic acid, we can get the tetrazones. 1, 2, 3, 4. 4 nitrogens are there. That's why we can say these are the tetrazones. So this is a completion of Schmidt reaction.